Okay, let's talk about the pattern of magnetic field, magnetic lines of force around a magnet. Pattern of magnetic lines of force around a magnet. Okay, so we said in our last video the magnetic lines of force are those lines, imaginary lines drawn around a magnet, the direction of which at any point gives the direction a north pole will go at that point. So let's say we have just a north pole here. This is a north pole. So what is the pattern of magnetic field around it, which will be shown by the magnetic lines of force? Now, the direction of the magnetic line of force around a north pole are such that they go out, away from the magnet itself, from the north pole. Magnetic lines of force around the north pole are such that they go out. Now remember, I told you something, that the north pole of a magnetic field is analogous to the positive charge in an electric field. And just like in a positive charge, in a positive charge, you have the electric lines of force around a positive charge are such that they also go out as well. Now you can think of this like the metals in the periodic table. The metals, they give off electrons, so they become positively charged. You see, so they have to give out. That's why the lines go out. So in the same way too, the lines of force around a north pole in a magnetic field are such that they go out. You see, so this is why the two are analogous to each other. So how about the pattern of magnetic field around a south pole? Let's say we have a south pole here. A south pole. Now, as you may imagine, it will be the opposite of this, of course. That means they'll be coming inside. You see, they have to be coming inside. Now, the reason for that, again, just like I explained with the analogy between the north pole and the positive charge, in the electric field, the negative charge, the negative charge is such that the lines of electric force, the electric lines of force around it, they come in. And of course, you can use the non-metals in the periodic table to understand this. They gain electron. For example, chlorine. Chlorine gains electron to become it gains electron and then to become negatively charged, and that means the lines of force will have to come inside because it gains. So this is why the south pole is analogous to the negative charge in an electric field, because just like the negative charge in the electric field, the lines of force around the south pole are such that they come in. You see. So now let's talk about the pattern of magnetic field around a bar magnet. Now, what is a bar magnet? A bar magnet is simply a metal bar that can actually attract or repel other magnets depending on the pole. Is a bar such that each half has the two polarities, the two poles of the magnetic field. The two polarities of magnetic, which is the north pole and the south pole. So this is the south pole. So the pattern, if it goes this way, it comes like this, like this. Comes like this, like this, like this. Of course, this one goes like this. You see, now the lines of force from the North Pole goes out, while the lines of force from the South Pole comes inside. And that means this one is going to be drawn in this way. You see, from the North Pole, they run from the North Pole to the South Pole. And of course this one goes here, and this one comes in. This one comes in, comes in, comes in as well. Here, here. Of course this one goes out, goes out, goes out. Sorry, this one is a mistake. And then it goes out. So this is the part of the magnetic field around a bar magnet. And if you sprinkle, if you have a bar magnet on the paper and you sprinkle some iron filings around it, they quickly arrange themselves into this pattern. It's a very beautiful pattern. Something like this. So now let's talk about the pattern of magnetic field around two magnets of similar polarity, of the same polarity. So let's say we have a North Pole here and another North Pole here. What is the pattern of magnetic field around them? Of course, you know, magnetism and electricity are very much alike. You know, like you've already have noticed with the examples that I've given. You know, in electric field, we say like poles repel or like poles attract. It is the same with magnetic field as well. Like poles repel, you see. Now these lines of force, due to this magnet here,